In this lecture, we are going to talk about set and map. So let's get started with set. So a set is an interface. See here, it's an interface that extends the collection interface, as you can see here. So under collection, we have set, we have queue, we have list that we talked about, and then abstract collection. And under set, we have the abstract set, sorted set, and then it goes down to tree sets. So tree sets basically we have the elements sorted in a given order. And then we have the hash set, basically just random order. Okay, so we'll talk about hash set in detail. As you can see right here, set is an interface. It's not a class, it's an interface that extends the collection. And then under set, we'll be talking about hash set and tree set. We can have examples of each and how they work, what kind of level they have. So set is different than list. Both of them are interfaces that extend the connection, but each one of them works in a certain way. So for example, a list is a sequence of elements, not necessarily sorted, but there is an order that index-based, like index 0, 1, 2. So the elements are following a certain order. The list can have duplicates, but the set cannot have duplicates. That's probably the main difference. But this is the definition of set. A set is a no-sequence, so there is no index here, no-sequence collection of distinct objects. So we say distinct because it does not accept any duplicate. So when you try to add a duplicate, of course, the program will exclude that element, will just ignore it. The presence or not of an object is important. And then we're talking about some of the operation like the union, the section, the difference, and subset. So this is an example of set. So we'll talk about the map later. Now let's talk about the methods that we're going to be using frequently when dealing with sets or the classes that implement the set interface. Is empty, of course, it checks if the set is empty or not. And then the size, keep track of how many elements in the set, contains check if the object exists or not. And then you can add the element, you can remove, and then you can use the iterator to cycle through the set. So now let's switch to Eclipse so we can have examples how the set works. Now to declare a set, of course, we need to choose one of the two classes that implement the set interface. So we can either use the hash set or tree set, depending on whether the order, like putting the elements in order, is important. If it's important, then choose tree set. Otherwise, choose the hash set because it's faster as far as performance is concerned. So let's declare a set. Let's start with hash set. So this is how we declare one. We can either declare it as interface, like this. And then we can mention the name, say s equal new hash set. And then you put the data type. Okay, so that's how we create, or you can put hash set on both sides. So you can do it this way, or you can put the name of the image, but you cannot put interface here, because in the interface we cannot create objects. We can create objects only through classes, not interface. So if on the right side you can either put hash set or tree set. So let's start with the hash set. So now, by default, when you create a set for the first time, hash set or tree set, then the size is 0. So if I want to display the size, of course, it's going to say 0. S, that size. So if I run the program, it should say 0. And then I can add elements. So I can put s dot add, and then I can add some names. mark because they are of type string. Then we just copy so it gets faster. So we're going to add. Remember, it does not accept duplicate. Duplicates, it will just be ignored. So we are adding Bob, we are adding Steve, and then we are adding, let's say, Keith. Now let's print these elements. How do I print them? So we'll just copy system output one, so we don't have to keep typing it every time. So now you're going to pay attention that there is no order. So you can, the program will display the element in a random order. So if I put S and then I run the program, so they will not be displayed according to the sequence or the order they will receive. We start with Mark first, but Mark now is at the end. So we have Bob. So it's a random order. But if we use the tree set, then it will be in order, in alphabetical order in this case, or in the standard order. Okay, now let's try to add another element that already exists. For example, I'm going to add Mark. So if I try to add Mark, what's going to happen is it will be ignored. It will not be added because we already have Mark in the list. So that's probably the main benefit. That's the main reason why people would want to choose set over, for example, arrays or other data structure, because it does not allow duplicates. So it saves a lot of time instead of using an F statement to check if the number has duplicate or not. So the set will automatically take care of that. As you can see, I printed the set and then Mark is mentioned only one time. Now, let's print that statement because the add method, it's a return method. It returns true or false. So for example, if I try to print this and I want to print it, what do you think I'm going to get? When I run the program, it's going to say false. What does false mean? False means the operation of adding Mark to the set was unsuccessful. Why? Because we already have one. So if you return false, that means the addition, that operation that you were planning was not successful. So it was not added to those sets, okay? Now it is going to return true if the element is new. Like for example, if I want to add a new element that did not exist before, like for example, right here, as add Maria, for example. So here is going to return true. Why? Because the addition was successful. I was able to add Maria because it's nothing. It returns true because I was able to add it. Maria, we don't have Maria in the set. So the addition, that operation of adding a new element was successful. Okay. So this is the hash set. Okay? Now let's use an example of a tree set. You can see the difference. Declare tree set. Objects. Declare and create a tree set object. That's going to do the same thing, but the difference is we're going to put tree set. Let's this time choose integer. So I'm going to put here S1. New, again, tree set integer. Now, as I said, we can replace this with the name of the interface. That's fine. Okay? So you can put the name of the interface on the left side, like for to declare an object, but not here, because here only the class name should be mentioned. So now I have, it's back, it was to set. Now by default it's empty, and then I'm going to add numbers. Just like with the hash set, the only difference is the order. Order will be respected. So I'm going to add S1, that's add, I can add numbers, let's say 9. And then again, it does not accept duplicate, just like the hash set. And the older set don't accept, regardless whether it's a tree set or hash set. So it does not accept duplicates. So we have 5 here, 2, and then we have 1. So if I want to print system out print line S1, it's going to print them but in order, in ascending order, as you can see right here, 1, 2, 5, 9. So again, if the order is important to you, then choose a tree set. If it's not important, it is better to choose hash set because it is way faster. Okay. So now S1 has now, let's try to add an existing element. If I put add, let's say 5, of course, it's not going to have impact. We already have 5 in the set, so it will be the same thing. Okay. Now the next question: how do we cycle through the set? So we have different ways to do that. So how do we cycle through the set? So I can either use the for each loop, so that's the one works with all types of collections. So we can use string s, and then what's the name of, I'm sorry, here, yeah. So let's say here for every name in the set, I can print, for example, system out, print, let me print them horizontally. So I'm going to print name, then space. So this is one of the easy way to cycle through the set so you can print or whatever you want to do. So if I run the program, as you can see, it shows all of them. Okay. Now remember that for each loop or the enhanced loop allows you only to access the element, but you cannot change anything using the for each loop. It's very important to remember. The for each loop, the enhanced loop, allows you only to access the element. Now, if you want to make some changes, then you may want to use another alternative way, like for example, using the iterator. Using iterator. The first one I need to create iterator object, iterator. So iterator basically allows you to visit, access elements of any collection, and then it allows you to make changes. You can remove certain elements, which you cannot do with the for each loop. Let's create the object. I can put, for example, right here, string. And I'm going to call it it. And then here I'm going to use the name, which is s. And then you call the method iterator. Now we're going to use the while loop. While it, which is the iterator object, has next. As long as like it looks pretty much like scanner, like the scanner class. Okay. So here, as long as while there is an element, then let's say I wanna remove. Okay, let me print it first. So I'm gonna put system out print line or print. Here, let me skip a line here. System out print line. Just to start a new line. So here, let's say I want to print it next. So we call the method next, so you can have access to the next element. Okay, and then maybe like a little space. So if I run the program, just like the for each loop, it's going to print all the elements, the names, just like that. Now, what about if you want to make some changes? Let's say I have names. I want to remove all the names that start with the letter L. So I cannot do it with for each loop, but I can with iterator. Say something like, let's save the element first. So I'm going to put it start next. Save it. Then I'm going to use an if statement that says if name char at, because name is string, I'm going to put char at, I'm sorry, n, I have only n. So char at 0, that is the first one. If the first one is equal to m, then remove it. How do I remove it? I'm going to use the filter because it has a method called remove. It's a remove. So now if I print the set, now if I print the set, this one, so it's going to show the set without Maria and Mark because they start with L. So let's run the program. Right here, Bob, Steve, and Katie, no Mark, no Maria. Okay? So this is the using iterate. Another thing we should know also about the set, you can do some operations like union, for example. Union, basically you combine two sets. So let's say we have two sets. Let's say S1, which you already have, it has a bunch of numbers. This number over here. And then we're going to add another, say, 3 set into, call it S2. New 3 set into. Let me add a few elements here. So let's say add 15. S2, let me just copy it. A 9. I say, and then 12, and then let's say 5, and 2, and finally 20. All right, now we have two sets here, S1 and S2. All right, let me print this system and print line S2. So you're going to see it will be printed in order from smallest to the highest, as you can see. Now, what about the union? Let's say I want to basically combine these two groups, these two sets. All what I need to do, I'm going to S1 that add all, and then the second set. So basically it's going to add them, but again, without including duplicates. So this will affect only S1. S2 will not be affected. S1 will change. It will basically contain all the elements in both sets, but without containing duplicates. So for example, if we want to display S1, attention here, S1, it's going to show me the elements in both of them. As you can see right here, all the elements in both 1, 2, 5, 9, 12, 15, 20. Now what about 2? The 2, it will stay the same or change because we have, see that, 2, 5, 9, 12, 5, 20. Okay. Right? All right, so this is the union. Now, what about, I'm going to put the copy. I'm going to comment this one out because I don't want it to affect my next operation. What about if I'm looking for the union? I'm sorry, the intersection. So we're going to find intersection. What does intersection mean? Because what about if you have two sets and you want to find the common elements? It's like you have two classes and you want to find out who are the names of students who are taking both classes. That's an example. Okay. So let's use the example that we have. Again, S1 at retain all. Retain all S2, that basically will give us the intersection. So if I put system out, print, and then I print S1, look, I'm going to have only the intersection. Which numbers I have in both? You can see we have three elements, 2, 5, 9. If I go to S1, we're going to find these elements. If we go to S2, we're going to find it as well. So these three elements exist in both. That's it. So if you want to find intersection element that you have in both, that would be a very good tool to use, good example. Now, of course, S2 was not affected, okay? That's intersection. Now, if you look finally, we're going to look at the difference. So the difference between two sets, so basically you are going to display the elements. It's like you're going to remove the common elements and then you display the rest, the difference. So as you can see right here, I can put S1 that remove all S2. So what do you think is going to happen here? If I try to print system out print line S1. So if I run the program, look at S1, S1, we make sure it's S1 here before the change. So if I run the program, this is what S1 looks like. See, we have 2, 5, 9, 12, 15, 20. Okay. And just here, so S1. So let me print both of them here. Then S1 and then S2. All right. So that's S1. Out and I just want to separate them so we don't get confused. All right, so let's look after that line of stars. So the S1 is 1, 2, 5, 9. S2 is 2, 5, 9, 12, 15, 20. So the common one, so if you remove 2, 5, 9, which are common in both, you have only one left. So that's the difference. S1 is 1, 2, 5. So remove any element that belong to the intersection between the two sets, which is 2, 5, 9. What do you have left? 1. Now, what about if we do the opposite? It was S2 and then S1. That means it's going to affect S2 now. So what do you think is going to happen? Again, it's the same thing. You remove the elements that belong to the intersection, and then you display the rest. So this is S2. As you can see, 2, 5, 9, they belong to the intersection. They exist in the others. So we remove them and then we leave the rest, 12, 15, 20. So that's generally speaking how the search works. If you have any questions, please do not hesitate to let me know. Thank you.